Okay, all right. Good evening, everyone. Welcome to today's session. Um, we're just today we'll continue our discussion on memory and context management, and we're going to look at the agentic retrieval today. Last week we talked about context management, and just to do a recap, we talked about the core components of the context, which includes the system from system message, comprise the persona and system instructions. It includes the user inputs. It includes truth information. It includes tool schemas, responses, and so on. And we also talked about why it's the necessity for managing the context, particularly considering that the context window is limited. So once the context fills up, something has to give. And also, especially considering that as the context window fills up, the agent's performance drops, um, including increased latency, as well as increased API costs, as when you're using a paid service for the LLM. And there's also the stack problem where, given that LLMs tends to remember more the information at the beginning and at the end of prompts, and they tend not to remember the information at the middle of the prompts. So we talked about different strategies for managing context, including sliding window, including compression, and so on. We also talked about the best practices for context management. Today, as I mentioned at the beginning, we'll be talking about agentic retrieval. Just to lead us into the discussion on agentic retrieval, let's look at what retrieval augmented generation, because agentic retrieval is simply retrieval augmented generation, except that in this case it's done in an agentic manner. So retrieval augmented generation, or simply RAG, which is the acronym, which is what it's typically called. It's like giving an open book to the LLM, where it can look up answers. I mean, the LLM is trained from its internal weights. It already has knowledge baked into its weights, and so we can respond based on that. But any information that's outside the knowledge based on which was trained, it's part of answering questions that require such information. So RAG enables providing such information as context to the LLM. And so it can look in this open book to get relevant information for prompts that require information that's outside what has been baked into the LLM suites. It involves essentially fetching relevant information from, say, vector databases or from external APIs, or even from the internet, like websites, and then using such retrieved information as the basis for the LLM generating the LLM's response. The value that this provides is that it anchors the LLM's responses on verified information, thereby minimizing hallucination and misinformation. RAG allows the LLM to get access to specialized knowledge and private knowledge bases. LLMs typically are trained on publicly available information, the internet, So, but there are some specialized knowledge that are not publicly available. So RAG allows the LLM to get access to such private knowledge and to use that knowledge as context in providing its responses to user queries. One of the advantage of RAG is that it helps you to avoid having to constantly retrain and fine tune your LLM, because without RAG, if you want your model to have new knowledge, then you have to fine tune it with that knowledge. But with RAG, you can inject that knowledge into the context at runtime. RAG is quite essential. It comes out to be very essential to improving, developing reliable, trustworthy, and context-aware AI applications. Reliable in that it provides reliable information, injects reliable information in the context, like you mentioned, minimizing misinformation. That also relates to trustworthy and, of course, context-aware, because you're providing the necessary context which might not be available in the prompts. So you retrieve those from some external source and inject that into the context. The typical use cases could be like customer service chatbots, internal document search, compliance monitoring, and so on. Any use case that requires specialized information that might not be already baked into the LLM's ways, we benefit from that. Any questions so far?
No from my side, sir.
Okay. Kenneth, you have a question, please go ahead.
Okay. Can you hear me?
Yes, clearly.
Yeah. Nice. Okay, so I want to ask, can we then refer to RAG to be a tool? Because since it adds some capabilities that the LLMs might not have, so could we then refer to them as a tool?
The tool. Well, RAG is not a tool, it's an approach, it's a strategy. It makes use of tools, but it's a strategy for grounding the LLM in relevant context. So RAG is not a tool, it's a strategy.
Okay, and I will note it.
All right. Any other question? Okay, so we'll move ahead. Now, the traditional RAG, in traditional RAG, when the LLM receives the prompts, it retrieves necessary information from whatever knowledge base is available to it. It uses that information to augment the context, and then based on that augmented context, it generates the response to the prompt. So that's why it's called retrieval augmented generation. Now, this traditional RAG is like a linear process, right? When the query is complex or ambiguous, it's not very reliable. It's more like a one-shot approach to generating the LLM's response. But instead of this, instead of using the traditional RAG approach, if you now grant an agent RAG capabilities and giving it agency over that retrieval, such that it can decide which search tool to use based on the given context. It's like a roundabout thing, using context to refer to context. Based on the specific use case, the agent is able to decide which specific tool to use in retrieving the information with which it will augment its context. For example, could use a web search, it could retrieve from a particular vector database or whatever the case may be. And then the agent is able to iterate through the retrieval process such that if the information retrieved is not adequate or is not relevant, it can retrieve again, try to retrieve again from the same source or from a different source, and so on. That tends to be more reliable, right? That adding agency to that retrieval process, retrieval and augmentation process tends to make it more reliable, and that is what we call agentic retrieval. Some persons call it agentic RAG. The major difference here is that the agent has agency, the LLM has agency over which tools to use for the retrieval, and is able to perform the retrieval iteratively based on feedback loops. So it can determine when the retrieved information is adequate and relevant, and or otherwise, and then it takes appropriate action based on whichever situation it is. Any questions? Someone's hand is raised. Does anyone have any question?
Sir, please, can you kindly help go over this difference between the normal native RAG and agentic RAG? Do I understand you said the LLM has agency over this tool? I want to get it. Does it not make it an agent already?
Normal RAG is one shot, is linear. The LLM is prompted, it retrieves information from the tools that are retrieval tools that are available to it. Well, if it determines that if it's a query that it can respond to from its internal knowledge, it can respond to reliably from its internal knowledge, goes ahead. If it cannot, it tries to retrieve information from the retrieval tools available to it. It injects that additional information into its context. It uses it to augment its context, and then it generates a response. But sometimes the information it generates, it retrieves, might not be very relevant. It might be similar, but it might not. It might not be very relevant, and so you could have failures where perhaps it provides a response which, or even though it's grounded in the retrieved information, might not be relevant to the user's intent, especially where the query is complex or ambiguous. Now, one way of improving that is by granting it agency over that retrieval. Agency in that it must not retrieve, and it can decide which tool to retrieve from. It can also decide whether the information it retrieved is relevant and adequate. Where it is not, it can decide on what to do. Maybe try to retrieve again, it iterates back to retrieve again, or even tries to modify the query so that it uses a query that is more likely to retrieve relevant information, or you could decide to try a different retrieval tool, or so on. Essentially, it performs that retrieval in an agentic loop. It's no longer just straightforward one-shot retrieve, augment, and generate. It's retrieve, determine the relevance and adequacy of the retrieved information, then either you augment or you take some other action based on the analysis of the adequacy and relevance of the retrieved information. So that's basically the difference. It does. Okay, you're welcome. So we continue. Now we'll look at the pillars of agentic retrieval, and they are primarily routing. I mean, that's what I just described, where the LLM decides based on whether its analysis of the retrieved information, it routes to generation, whereby it uses that retrieved information to augment its context, and then generates, or it decides to retrieve more information, or it tries to discard what it already retrieved and retrieve fresh information, either from the same retrieval tool or using a different retrieval tool, or whatever other action based on its logic. The other one is query transformation. This involves the agent, essentially the LLM in the agent, transforming the query, modifying the query so that it modifies it to a form that is more likely to retrieve the relevant information. So in this case, the LLM itself, the agent itself, modifies the query that it will search with. That's query transformation. Then grading. Grading is where the agent analyzes all the retrieved information and ranks them, and so that it will know which ones are more relevant to the task, and obviously those more relevant ones are the ones it will use to augment its context before generating the response. And the other one is iteration, which we already mentioned. It performs the retrieval in a loop based on its analysis of the relevance and adequacy of the retrieved information. So it can iterate through that retrieval cycle until it's able to retrieve relevant and adequate information with which it then augments its context and generates the response. Any question? Okay, so agentic retrieval patterns. So what are the different approaches to agentic RAG? The first one we'll talk about is adaptive RAG. Essentially, adaptive RAG is about routing queries based on the complexity. For example, if the query is a simple one, the agent could answer from the internal knowledge of the LLM. That's the knowledge that has been baked into the LLM from LLM parameters, its weights. If it's a domain query, a query that is how do I a query that is based on a specific domain, then the agent's execution is routed to, or rather, the agent will try to retrieve from specialized vectors to a vector store that is specific to that domain. It's a vector store that has information that specifically covers that domain. That helps to ensure that the context is augmented with more relevant information. And then if it's a current or say complex general query, then it could rack to maybe a website tool like Tavily of Brave. We've been using Tavily for some weeks now in our demonstrations for retrieving as our websites too. And in LangGraph, this is implemented using conditional edges to route the correct. So of course, that's where we want to use the explicit edges. You could also implement that in edgeless graphs. The important thing is that you route based on specific conditions related to the nature and the complexity of the query. Any question? Yeah, Kenneth, please go ahead.
Okay, sir. So I would like to bring this scenario up so that will clarify a couple of things for me. So you mentioned that RAG is a technique that we use. So maybe for this instance, okay, so let's say we are building an app for let's say a health firm. So the technique that we use is maybe like you will get the static like information of the health firm, maybe what they are about, what they do. So I get this, that using the probably using the one way retrieval is maybe when the user like queries and he or she will get the info. Now, how do we then connect the um, agentic like retrieval here? Because like I know that maybe if a user asks for like a certain maybe like predefined like question that has been stated like within the RAG. Now like the user like can get it. So how will the user um get like the other one? And that is the agentic like retrieval here. It's like can
The
you help me
user
on
is
that?
not the user is not getting anyone. You, the builder, determine which you want to use. If the use case is so simple that all questions that we routed to the LLM can simply be addressed by simple RAG, then you use that. It's simple. But if there's there's a whole variety of scenarios that you need your agent or your application to be flexible and to be able to address prompts across that different plethora of varieties, then agentic retrieval would probably provide more reliability in that use case. So it's for you to determine which one works better. If vanilla rag will deliver good, very good performance, then there's really no need to implement agentic RAG, which provides some extra level of complexity. I mean, use the simplest solution possible to that the simplest solution that will deliver adequate performance is most times the best solution.
Okay, sir. Like I guess like what you said. Like I get it like to the core. But like, can you give me a scenario where we will use the agentic like retrieval? Like, can you help me on
So
that?
we'll look at that. We have the demo code I sent. If you had looked at it, it uses agentic retrieval. I had sent that demo code in
Okay.
uh,
I've run it though.
yeah, we'll run it today.
I have.
So
So
you have
I
run it,
think
but did you look through the code?
yes.
That is
Like I
agentic
checked
retrieval. That's
the
agentic retrieval. There are different agentic retrieval patterns, right? What we are talking about right now is adaptive RAG. There are other patterns. So it's for you to determine which of those patterns. First, you determine that your use case requires agentic retrieval. Then what agentic retrieval pattern works best for the use case? You could combine more than one pattern. It depends on your use case.
thank you, sir. I appreciate it.
Okay. Even the demo codes that we've had in the past few weeks have really been using agentic retrieval. A prompt is given to the agent. Those are essentially like research agents, right? The prompt is given to the agent. The agent checks its memory, whether there's relevant information. If there's relevant information, it responds based on the memory. As it's getting that information from memory, that's a form of RAG. And if it doesn't find adequate information in memory, it uses the website to retrieve information from the web. And when it retrieves information from the web, it checks whether it generates a draft response. it evaluates that draft response to see whether it's adequately, it completely and correctly, I think that's the term in the prompt, it comprehensively and correctly or something like that, answers the question. And where it does not, it checks whether the information it already has is adequate for generating a good response. And if the information is okay, it just goes to write the draft based on the critique. But if the information is not enough, it still goes back to a web search. But first of all, it would transform the prompt to try to get a prompt that will most likely give more relevant information. That already is RAG because it's agentic. It retrieves information, it generates with that information, it checks whether it works. If it doesn't work, checks whether it needs to retrieve more. If necessary, it retrieves more. It's already retrieving in a loop based on feedback from what it has already retrieved. That's agentic RAG. And that reminds me one question now. By the time we are done with this class, I would like each person to go in the Discord channel, probably respond to the post I made today. Okay, I'll create a fresh thread where we answer what kind of agentic retrieval pattern we have been using in the demo codes in the past few weeks. Right? Okay. So we move ahead. A moment, please. Just give me a moment. Okay, sorry about that short break. Yeah, so we look at the next pattern. Corrective RAG. Now, in corrective RAG, the target problem is this. Sometimes when you perform RAG, even when you retrieve information, the information you retrieve is irrelevant. And if the model generates a response based on that irrelevant information, it will most likely hallucinate. So corrective RAG tries to solve this problem by including a grader node in the retrieval pipeline, the retrieval cycle. So the job of the grader node is that when the documents are retrieved, it just evaluates them to determine whether or not they are relevant to the prompt. And if all the documents are relevant, then the agent generates the response. But if not, then it transforms the query, tries to modify the query to make it one that is more likely to retrieve more relevant information, and then it searches the web for additional data, additional information, and then it uses the relevant information that it retrieved earlier and the supplemental information that it got from the web. It uses the combination of those to augment its context, and based on that generates a response which is more likely to be relevant and to address the intent. Any question? Okay, so we continue. Now, another pattern is the self-reflective RAG. Here, the idea is to evaluate the answer that has been generated based on the augmented context. Here, that is, the model has already retrieved information from some external source, used that rather the agent has already retrieved information from some external source, use that information to augment its context, and based on that augmented context, the model generates an answer. And with that answer generated, the agent evaluates that answer to see how grounded it is in the facts that are contained in the retrieved documents. And so, if the answer is grounded, is it useful, and does it actually address the question? So, if from this evaluation, the agent determines that the answer is grounded in facts, it's not hallucinated, it's useful, it answers the user's question, then it just outputs that. But if the answer fails this reflection, then the agent either loops back to the nodes to rewrite the query, such that it can use the transformed query to search again for information, or it tries to use that same query to perform another retrieval, maybe from some other source or whatever. But essentially, the idea here is to evaluate the generated answer itself, and based on that evaluation, determine whether it needs to perform another retrieval, or it even needs to modify the query before that new retrieval attempt. Any question? Okay, so we move ahead. Now, some advanced agentic retrieval approaches include multi-query retrieval, where the agent retrieves the user prompt, and then it tries to generate some multiple variations of that prompt, which are tuned to capture different neighborhoods of different vector neighborhoods, of course, related to the prompt. Like a given prompt could actually, we talked about vector space, right? A given prompt could actually better target a certain region in the vector space. So generating multiple variations enables it to capture the different sections of the vector space that are relevant to that prompt. And so it's able to provide a more grounded and obtain a more grounded and more comprehensive context with better coverage of the necessary information. So this most probably will lead to a more relevant response to the user prompt. Another advanced approach is re-ranking. This is by using cross encoders. Here, the agent retrieves much more documents than it really needs for answering the query, and then it ranks them and restores them by their relevance to that query, and it picks the ones with top relevance scores, and those are the ones it uses to augment its context and then generates the response. The third one will be contextual compression, where instead of retrieving the entire document, the agent retrieves only the relevant information from those documents. Let's say from an entire 1,000 word document, for example, it retrieves only a few sentences. The few sentences that have the most relevance to the user prompt. Any question? Okay, we'll move ahead. Another approach is multi-index and tool use. Now, a multi-index retrieval, essentially, you index the documents, the information, you index them hierarchically. For example, you could index summaries of the documents so that in the first instance, when a user prompt is retrieved, the agent searches that primary index, the index of the summaries. Given that the summaries have shorter length than the entire document, it's a faster search, right? So it's able to search through more documents. And then when it identifies the summaries that are relevant to the query, it then drills down through to the next index where it now checks specific document chunks that are more relevant. That way, it doesn't have to search large blocks of text. It searches relevant smaller blocks, which make for faster search and retrieval. Here, in this case, the agent could be acting like a librarian, while indexing is what librarians use. When you come to the library and you want to get a book on a particular topic, the librarian uses an index to know where is the shelf that contains books related to this topic. And that's like when the agent searches through the summaries index. Now, when it identifies the summary that contains that information, you now go to that shelf in the case of the physical library, and then you now search for the specific books that are more relevant to what you're looking for. In this case, in the agentic retrieval context, it's now searches through the different chunks from that related to that summary, and then it retrieves the ones that are most relevant. This help is like a divide and conquer kind of approach to agentic retrieval. Any question? Okay, we move ahead. So at this point, we'll look at the demo code. I'm going to stop sharing my screens, and then I'll share my IDE so we can run the code. Please let me know when you can see my screen.
Your screen is visible now, sir.
Okay, and you're seeing my ID. That's fine. So this code essentially demonstrates agentic retrieval. As we're going through it, I would like you to bear in mind, try to identify the agentic retrieval pattern or patterns that are implemented in this code. Right? There's really no new module that is imported here. All the modules that are imported here, we've encountered them in previous code samples. So just move ahead. The configuration is the same that we'll be using. Yeah. Now, state. Apart from user query, search query, which we've encountered, chat history, which we encountered when we were looking at buffer memory. We add some context management fields that are more specific to context management. Retrieval plan, that's the librarian strategy. This is where the agent, the librarian node actually, where the librarian node, based on the query, it drafts a strategy for retrieving the relevant information. So that retrieval plan is captured here. Then curated context is where the context that is retrieved, there's a node that curates it, that tries to condenses it to retrieve the most relevant information from it. So not just the key information from it, that's what that node does. And that key information is captured here as curated content. Raw results is essentially is a list of all the documents that are retrieved initially before re-ranking. And then after re-ranking, the most relevant one is now used and the context is curated. And research data, like we've encountered in prior demonstrations, is where it contains the retrieved context from the web search tool, that's Tavidi Search, as we're using. And relevant chunk index is just the index of the relevant chunk from after re-ranking. When we've re-ranked the different documents retrieved, then the most relevant one, its index, is captured in that field. Now, in our previous demonstration, we've just used one index. Here we're using two indices. We have two different search. We have for each prompt, each turn, each run, we will first search through the primary index to retrieve the most relevant summary. And then based on that summary, we'll search in the child index to retrieve from the chunks. Now, this helps filter out what we are searching in the when we drill down. So you only search the chunks that are related to the index that we identified in our search through the summaries. That way, we fine-tune the search as we drill deeper. You could do multi-stage. Here we're just doing two-stage hierarchical indexing system. You could do multi-stage, depending on your use case, but bear in mind, like I mentioned, I think in response to Kenneth's question, that the simplest solution that delivers good results is usually the best. Now, helper functions. Well, here, this just feeds data into our document store, enabling us to perform RAG. Well, in production, you would already have perhaps a vector database like a Pinecone, to where the domain data or specialized data or whatever information is already stored. Contextualized query is a helper we've been using from the previous demos. Essentially, what it does is to inject the context of the chat history and use that to rewrite the query as a standalone, so that if there's information, if there's some entity in that query whose understanding depends on context from the chat history, it injects that into that query, making it a standalone query that can be used for search, even in from a store that doesn't have that context of the conversation history. Now, our nodes, the librarian node. So the job of the librarian node is just to determine which search tool to use. Essentially, we are providing it like a catalog of two shelves in quotes two information sources, namely the vector store and the web search, and we provide it with some information about these information sources. For the vector store, the information is that it's best for factual information, thematic descriptions, and nuanced narratives. For web search, it's best for current and real-time use of missing data. And then the prompt is asking it to act like a librarian, that it should determine based on the query which shelf to check first. The shelves in this case are the vector store and the website. So we're asking it to act like a librarian in whose library has two shelves, vector store and web. Take a moment to switch back to my primary connection. They will continue. Okay. Can you hear me clearly?
Yes, please.
All right. Thank you. So essentially, what the librarian node does is to determine which of the information sources to search for relevant information, based on the prompts. And it's supposed to return a JSON object containing its reasoning. Well, firstly, most importantly, is next step. Next step here is either web search or researcher. Web search refers to, it will return web search if it decides that the query is asking for current information or real-time news or missing data. And then if web search matches researcher. So if it determines that the appropriate shelf is web search, it returns researcher with the string researcher as the next step. But if it determines that vector store is the correct shelf to search for that information in, the vector store is the correct source, is the most appropriate source to search for the information from, then it returns the text hierarchical retrieval. And then the next, so the JSON object contains the next step and also the reasoning, which is a string where the node, the librarian node, it provides its reason. It justifies that choice that it made, right? The next node is the hierarchical retrieval node, which essentially tries to retrieve information from the vector store, and it performs using hierarchical indexing. First of all, it searches for information on that query from the parent store, which is the store containing summaries. And then if it finds one any summary that is relevant, then it uses the ID of that document to search in the child store for chunks that are relevant to that summary, chunks that are related to that summary, and it's retrieving up to 10 search, the top 10 ones. And so relevant chunks are those in which the metadata of the chunk, the doc ID metadata of that chunk is the same as the doc ID metadata value for the summary. If we go back to look at the seeded data, we'll see that the documents that are seeded contain doc ID in their metadata. So the relevant chunks are only the ones whose doc ID is the same as that of the summary, which it determines to be the most relevant from the summaries that it retrieved. And then, well, if it can't find any relevant summary, or it finds relevant summary, but it couldn't find any related chunk to it, then it performs a web search. But if it's able to find both a relevant summary and relevant chunks related to that summary, then it goes to the ranker node, where it ranks those chunks to determine which ones are most relevant to the prompt, and those are the ones it will use in augmenting its context. Well, the researcher node is essentially the same thing we've been doing since. Essentially, it performs a web search using the Tavily search tool. The ranker node, it just evaluates the different chunks that were retrieved and ranks them based on their relevance to the prompt, and it just returns a JSON object with the index of the chunk that it determines to be the most relevant to the prompt. Yeah, you could decide to return the indices of maybe the top 3, in which case it probably be a list or whatever based on your specific logic that you decide to implement. But in this case, we're just taking the most relevant one, and we're returning its index. And based on that, we now go to the context curator, where we try to retrieve the most important information from that chunk that we've determined to be the most relevant. So we extract the key information from that chunk in the context curator node. And then with that key information, we use it to augment our context in the writer node, which also generates the response, and that response is printed out to be displayed. Well, it could also be returned as an API response or be persisted in, say, a database, depending on the use case. The rest is just building the graph and then executing it. Now we have three turns. The first turn is just asking when was the union of Tanganyika and Zanzibar. That information is already in our vector store. And so it's expected that the agent will retrieve that information from the store and use that to augment this context, and that it will provide a response that is correct. The second query is a follow-up where it asks who was the first president of the resulting country. Now, we don't know what the resulting country is. So the agent is supposed to contextualize this query from the conversation history. So whatever the response in turn one, whatever country that was provided in the response in turn one, is going to use that to contextualize this query in turn two. And based on that, it will also perform retrieval, hierarchical index-based retrieval, because the relevant information is also already in the in our vector store, and it will use that information that is retrieved to as basis for providing the response. And then in turn three, is still a follow-up. Now, the query in this turn, the agent will also contextualize it from the conversation history, but then the information requested is current information. The query is saying, and who is the current president? Now, it's going to contextualize it, president of what? It's going to contextualize this query from the conversation history by determining that you're asking for the current president of the country that was mentioned in prompts in turn two. And then, given that you're asking for the current president, that's current information. And so the agent should be able to determine, the librarian node should be able to determine that since this is asking for current information, the best source for retrieving the information will be a website. And so the agent should perform a website, retrieve that information, and use the retrieved information to augment its context and then provide the relevant response. So we're going to execute this code, and then we'll see whether the agent actually does what we expect it to do. Okay, while we're waiting for the code to run completely, does anybody have any question or observation? You can also run the code on your own machine. So we'll see if we have the same results. You could modify the district model used. So that would also help us see how the response varies based on the specific chosen model. So I think yeah. So turn one, this is the user query, and then the search query, well, it's essentially the same thing. There's no other context to provide. And now here's the decision of the librarian node, rather. It decides to perform hierarchical retrieval. It decides that the vector database is the most appropriate source for retrieval here. And its reason is that the query is asking for a specific historical event, which is a factual piece of information. And it says that the vector store is best suited for that, and so on. And it performs the retrieval, and it was able to find relevant information. It was able to retrieve relevant chunks, and we can see the documents, the chunk documents here. The first one is saying Tanzania was formed by the Union of Tanganyika and Zanzibar in 1964. Any other one? Yeah. Another one is saying that Julius Nyerere was the first president, and so on and so on. Now, the most relevant chunk is the one that says Tanzania was formed by the Union of so and so. And so that's the one it determined that that's the most relevant, which really matches the use case here. And it was the very first one. So the relevant chunk index is 0. The agent is performing reliably and quite well up to this point. And then the curator node is supposed to retrieve the most relevant information from this selected chunk. And the question was, when was this union? And the most relevant information is the date, 1964, and that's what it retrieves. So it's going to use this information to augment its context. Now, the important thing, the function of this bottleneck node is that instead of injecting the entire document into the context, it's just injecting just 1964. That is also helping you to manage context so that you don't overload the model's context with the resulting performance issues. And then it writes the final response. The Union of Tanganyika and Zanzibar took place on April 26, 1964. Here, the model is also using its internal knowledge, resulting in the formation of the United Republic of Tanzania. Turn 2 is asking, who was the first president of the resulting country? And the search query is the contextualized query. And here, it says first president of the United Republic of Tanzania. It has already injected that information, which was not in the query, from the history, chat history. It has used to contextualize that query to say that, indicate that the query is asking about the first president of Tanzania, the United Republic of Tanzania, actually. And then the librarian node also decides that, this is hierarchical information. It needs the vector store is the best source to retrieve information from in this case, and it performs a retrieval and is able to get related chunks, which include this one that's saying that Julius Nyerere was the first president of Tanzania, and this one that also said when the union was done. Well, you see that he has, and there's also this one that's talking about the dominant ruling party since independence. But you can see that here, actually from the search, is rating this as the most relevant. Riranka also agrees. So the most relevant chunk index is 0, which is the one that's talking about Julius Nyerere being the first president of Tanzania. And then bottleneck node curates just the name Julius Nyerere, very concise, which is injected into context. And based on that, the LLM responds that the first president of Tanzania, the resulting country from the Union of Tanganyika and Zanzibar, was Julius Nyerere, and it goes ahead to provide other information, which it really obtained from its internal knowledge. Now, if you don't want it to be these verbose, these responses, you should update the prompt of the writer nodes, maybe to specify the concise and so on and so forth. So in turn 3, we are asking who is the current president, and it contextualizes to say current president of Tanzania, and it provides the decision is that it should set from the web, and it provides this reason that the query requires current information about president of Tanzania and so on and so forth, so which is likely to change over time and may not be really available in static databases. So, and that's correct reasoning. the Tavilisa tool retrieves information about the current president of Tanzania, and that information, from that retrieved information, the curator node just curates the name and since when the person has been the president, and that information is used to augment the context of the agent, and it responds. The current president of Tanzania is Samia Suluhu Hassan, who has been in office since 19th March 2021. And essentially, that's agentic retrieval. So my question here will be, can you identify which agentic retrieval patterns were implemented in this code? Pattern or patterns? Can you identify which pattern or patterns were implemented in this code? Okay, you don't have to answer now. That will be part of what you answer in the thread I will create. So your response will be one. What pattern was implemented in our demo code for last week? I think the one on procedural memory. And then two, what pattern or patterns were used in our demo code for today, our demo code for agentic retrieval. So I'm going to create that thread in the Discord channel, and we should all respond to that thread. And as you don't just provide the answer, also justify that answer, provide the reason why you're choosing the specific patterns that you mentioned in your answer. Any question or comment? If there is no further question or comment, then I guess we should call it a night. Yeah, and next week we'll start looking at ethics and safety in agentic AI. All right then. Good night, gentlemen. I'll stop recording and close the call here.